All right, so for 6.4, we're going to look at one more point of concurrency. We're going to kind of look at two, but we're really only going to use one of them, and that's the centroid, which we studied a little bit in GeoGebra, but now we're going to use it to do some math similar to what we did in 6.3. So centroid is this point right here, and it's labeled point P on my diagram. You're going to want all of this information in your notebook. You're going to need it. So the centroid, a couple of things about the centroid. First of all, I'm going to actually start here with the second bit of information. It says the medians of triangle ABC meet at point P. So it uses this word, whoops, that's not what I wanted. It uses this word medians. And I want you to remember that a median connects a vertex to the midpoint across from it. Okay, that's what the medians do. So if I start at B, the median goes from B to the middle of the point, to the middle of the line across from B. So if you notice on this diagram, they've labeled F to be the midpoint by there's 3 lines to the left, 3 lines to the right, which tells you that this piece and this piece are the same length. So that tells you F is in the middle, right? So the centroid is created by connecting the corners of the triangle to the middle of the line across from it. Now, there's some characteristics about the centroid. One of those is that the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. I don't expect you to memorize that phrase because it's a very confusing phrase. What it means is, let's do some color here. I've got this pink piece and I've got this red piece of the median, okay? The centroid breaks this median up into a ratio of 2/3. So if P to B, if that pink part is 8, then F to P is half that far. So the distance from P to the corner is twice as far as the distance from P to the midpoint. So if I keep going, if I make A to P this green line, and let's call that 10, then the distance, we'll do purple, from P to E, from P to the midpoint is half of 10, which is just 5. All right, that also means that if from the midpoint to D, if that distance is 2, then if I go from P to C to the corner is twice that far, so that would mean that P to C is 4. Now, I'm just making up these numbers. They might not even work in an actual problem, but that ratio is always going to be the same. The distance from the corner to the centroid is twice as far as the centroid to the midpoint. And notice that they're all different. None of these lengths are the same as each other, and they're not supposed to be. It's a little bit different than what we did last time. So let's do some math with that. So in triangle RST, point Q is the centroid. So this is the centroid. And SQ is 8. Find QW, so it wants me to find this distance, and SW. Okay, so it wants me to also find the entire distance. So let's start with QW. Well, if Q is the centroid, then that means the distance from the centroid to the corner is twice as far as from the centroid to the edge, to the side. So if this distance is 8, then this distance is 4. So I can say that QW is 4. And if that's 8 and that's 4, then I can say that SW has a distance of 12. All right, let's do another one. There's 3 paths through a triangular park. All right. Each path goes through the midpoint of one edge to the opposite corner. All right. So this is a midpoint. This is a midpoint. This is a midpoint. And the path goes from the midpoints to the corners across from them. Well, that's good information because that tells me, surprise, surprise, that this is the centroid, which, we're learning about the centroid. What other point would it give you? Okay, it wants me to find PS, so it wants me to find this distance, and it wants me to find PC, it wants me to find this distance, if S to C is 2,100 feet. Okay, if this entire distance right here, let's not use blue. If that entire distance is 2,100, then what's the pink part and what's the blue part? Well, I know that the blue part has to be double the pink part. So one way that you can do is start guessing, right? You can say, oh, well, if the pink part is 600, then the blue part would be 1,200, and that's not big enough. So how about if the pink part is 700, then the blue part would be 1,400, and if I add those together, that gives me 2,100. All right, good. So SP is 700, and PC is 1,400. All right, let's try another one. Find TC. So it wants me to find T to C, and it wants me to find B to C. Okay, it wants me to find this distance if B to T is 1,000. All right, so B to T right here. That part, green was an awful choice. That part is 1,000. Okay, well, because P is the centroid, and it told me that this line connects to the center, the midpoint of that side, I know that this piece, the green piece, and the pink piece are the same because T is in the middle. So that means TC is also 1,000. And if both of them are 1,000, then that means the entire thing is 2,000. So TC would be 1,000, and BC would be 2,000, that entire distance. Okay, let's do another one. PA, find PA. So I'm looking for this distance, the black distance, and also find TA. So what is this entire distance? If PT is 800. So if this right here is 800, well, I know that this is the centroid. And so I know that this distance is half of the black distance. So if that's 800, then this is 1,600, which means the entire distance is those two added together, which is 2,400. So PA is 1,600, and TA, that entire distance, is 2,400. We're not going to do 4 and 5. Don't worry about those. Orthocenter. The orthocenter is really cool, but it doesn't do anything as far as helping us solve algebraic problems. So don't worry about the orthocenter. It's not going to come up. The information's there, but it's not like the centroid that gives us these really cool, this side is equal to this side, and this piece is half of this piece. That doesn't happen when we're dealing with the orthocenter. So we're not going to worry about taking notes and using the orthocenter too much on this assignment. But what I do want you to do is numbers 3 through 14, which are going to use all of these different aspects that we talked about, okay? So homework 3 through 14, 11 questions, shouldn't be too bad. They're all going to be different. They're going to be asking you for different things and giving you different pieces of the triangle. And use that information to problem solve your way to whatever it is they want you to find. Come see me if you need help.